Today's just going to be an introduction into the waves topic, so we're going to go through a few terms and a few definitions that you may need to know for your exam. The first is the amplitude, which I've labelled A on this typical wave diagram. So what is the amplitude? Well, it is the maximum displacement from the rest position, or from the equilibrium position. And one thing that you just need to know is that the intensity is directly proportional to the amplitude squared, or the intensity can also be denoted by power. This is something that you may not understand now, you just have to take it for granted, and I'll try and explain it in one of the later videos. Now, frequency is the number of complete wave oscillations, or complete oscillations, that pass a point per second. The wavelength of the wave, which I've denoted on the diagram by this symbol lambda, is the distance between two adjacent points which are in phase. And again, that's something that we will talk about in another video. Now, the time period of a wave is the time taken for one complete oscillation. And using these definitions, we can see that this means that the frequency is equal to 1 over the time period. Now, another quite fundamental equation is that the wave speed noted by this v here is equal to the frequency of the wave multiplied by lambda. So the frequency of the wave times its wavelength will give you the speed at which that wave is moving. We talked about amplitude being proportional to intensity. What amplitude actually represents is really the intensity, or you could say the power of the wave. Or this basically means how much energy the wave carries. But you might now be wondering, well, how are waves created? How are they formed? Well, waves are formed by the oscillation or vibration or movement of particles. So let's say I have some way of vibrating these particles such that they form a wave. And in this case, they form a wave like this. Now let's say I decide that this wave is going to move in this direction here. So let's say a time of t over 4 seconds has passed, where t is the time period of the wave. It means that this wave pattern is going to shift to the right by a certain amount. Each particle will take the position of a particle that is 1/4 of a wavelength before it. So what that means is basically particle 3 will take the position of particle 1, so it will move to this equilibrium position. Particle 5 will take the position of particle 3, so it will move up. And you could do this for all the particles, and you'd get a wave that looks something like this. So after t over 4 seconds have passed, the black wave will now have moved to the position of the red wave. It moves to the right by a distance of 1/4 of a wavelength. Now, the best piece of advice I can give you after watching that video is to go off and practice some past papers or topic questions. These are single-handedly the best way to help you commit the content you've learned to memory. Obviously, go and do all the YouTube stuff of liking, subscribing, and if you found this video helpful, feel free to go and watch any of my other ones.